So like I said, today we are going to begin automatic and dynamic memory allocation. So automatic memory allocation is something that we've been doing already since, right? The moment you declare a variable and you initialize something in the variable, that's automatic allocation. You don't have to deal with the amount of memory that is to be allocated to that variable. It's done automatically by your operating system. Actually, there are some drawbacks of this automatic memory allocation. There are some drawbacks to that. That's why dynamic memory allocation is being introduced. So like I said, in the normal case or the previous cases we've been seeing, these memories are allocated to us automatically, right? The moment you do something like this, int I, right? This is an integer, right? This is an integer, and we said on a 64-bit machine, 4 byte is being allocated for integer, right? 4 byte will be allocated. So here, the moment you do something like this, 4 byte is automatically allocated to this variable I here. Do you get it? So the moment you initialize the value of I, let's say you put something like I is equals to, I is equals to 10, for instance. So the value 10 is going to be stored in the memory that is being allocated to you, right? This is automatic allocation. So there is one thing about this automatic allocation here. One of the drawbacks is that now, for instance, if I have a file that contains, let's say, 200 characters, for instance, the file contains 200 characters, and I want to store all these characters in an array, right? I want to store all these characters in an array. So if I do something like this, I can simply say car, right? And let me just name the array A like this, and then what's the size of the array? Let's say 200, right? If I should do something like this, and then here I pass in the file name, then what? We all know that the content, that's the characters in the file, is going to be stored in this array, and the size will fit, right? Because the characters in the file is 200, and also my array here is 200, right? So it will fit. So what if I don't know the size, or let me say, what if I don't know the number of characters in this file here? I cannot assume. I cannot say car. If I say car now is equals to, let's say, 150, for instance. If I say 150 here, and then I pass in the file name, and let's say the file here contains just 100 characters. If it contains 100 characters, and I'm creating an array of 150 characters to store what? To store characters of 100. So as you can see here, it will store, right? 100 characters will be stored here, will be stored in this array, but there will be remaining what? 50 bytes here. So what will happen? This 50 byte is now what? A waste, right? This 50 byte is now a waste. So, and like I keep on saying when we're talking about pointers, the memory is a very, very crucial resource. So you have to take care of the memory. Okay, the size of the memory is very, very small that you might not bother about it, but I assure you there are cases where you need to consider the size of your memory. You need to consider the size of the program. You need to consider the amount of memory your program is consuming. Okay, so as you can see in this case, this 50 byte is now a waste, right? And we are not supposed to waste any memory, right? So what if this place now, instead of 150, it is now 180? So as you can see here, it has exceeded what? The size of the array. So I cannot store 180 characters in an array of what? Of 150 bytes. It's not possible. So this is not possible. This is going to give an error. Okay, so this is one drawback of what? Of the automatic allocation here. In this case, as you can see, if our array, if the size or if the content we're trying to pass to the array is more than the size of the array, we will get an error. If it is less than the size of the array, we are going to get what? We are going to get, we are going to have 50 byte waste, right? And this is not a good thing. So that is why dynamic memory allocation comes into play. Okay, so with dynamic memory allocation, you as the user or the programmer or anyone calling your function, for instance, you can tell the function the amount of characters, considering this same example of 180 characters here, right? Me as the user or the programmer, I can simply tell the function the number of characters that I'm trying to pass to it, right? And the moment I tell the function the number of characters I'm trying to pass to the function, then the function will automatically, or let me say the function will dynamically allocate memory that will what? That will accommodate that set of character. Like I said, in this case here, I'm trying to, considering this same example of 480 characters, I can simply pass to my function that, okay, I want to what? I want to store 180 characters into this array here. And then the size of this array now depends on what? On the number of characters I pass to the function. Right? So if I pass 180 characters to the function, then what will happen? Then the function will dynamically allocate memory that will what? That will fit in the size of my characters. Right? So let's see a simple demonstration. Let me just try to demonstrate this here. Let's say, like I say, I have a file which contains 180 characters here. So we said we cannot create an array like this and then assume the size of the array and then pass the file name here which contains 180, right? The number of characters. We cannot do something like this, right? Because what? When we do something, actually this is okay. This is 180. The size of the array is 180 and also the size of characters is 180. So if I have 190 here, we know that this is not possible. This has exceeded what the size of the array. So to dynamically allocate this memory or to create an array that will store these characters for me no matter the number of characters, I use what? I will be able to use what? I should use the dynamic memory allocator, memory allocation function, which is what? Malloc. We have the Malloc. Actually, there are 3 functions, I think, or 4 of them. There is the Malloc for memory allocation. There is the realloc for reallocating memory as well, and there is the free. I can remember Malloc, realloc. There is calloc as well. But in this case, we are only limited to what? Limited to the Malloc in this case to allocate the memory. So the Malloc simply means memory allocation. Some used to say memory allocation, some used to say memory allocator. Anyhow, you just understand the concept memory allocation. So for you to be able to use this Malloc here, you have to know what a pointer is. Okay, you have to know what a pointer is, because by default Malloc returns a pointer, right? Let me see this. Let's see this. So the prototype of Malloc, before I explain the return type of pointer, let me write the prototype of Malloc and explain everything about it. So Malloc contains, or this is the prototype of Malloc. Malloc, then what? Then, sorry, this is a bit big. I can see it will consume the screen. So the first, sorry, is what? Is void here, right? With the asterisk here. Then you what? Then you add Malloc here, and then what? Size with an underscore t, and then another size here. This is what? This is the prototype for a Malloc. So what does this mean here? Right? So what does this mean? So the first thing here, as you can see here, this is the function Malloc, right? Memory allocator. So what does this size t means? This size t simply means that you can what? This size t simply means that this is an unsigned int, right? Whatever you are passing here is an unsigned int. It cannot be negative. That's just what this is saying. This is just simply saying unsigned int. You cannot have what? A negative sign or a negative size. You cannot have a size in the memory to be minus 10 minus 4 or something like. It's not possible. So that's why this is minus, this size underscore t is here. It's just trying to tell you that this size here you'll be passing must be an unsigned int. So this is just like you saying something like this. Let me rewrite this. This is just like us saying void here with the asterisk. Then I will say Malloc like this. Then I will say unsigned int, then size. This is the same thing as this. So this size underscore t is just simply telling you that your size here must be an unsigned int. You cannot have a negative size. I've already explained that. So now, what is the size here? What should be the size here? In this case, if you want to allocate memory, right? If you want to allocate memory for an integer, right? If you want to allocate memory for an integer, let's say I have int I here, for instance, and I initialize it to hold the value 4. So if I want to allocate a memory for this I here, I can do something like this, void Malloc, like this, right? And then this is just saying, this is just trying to show us that it has to be an unsigned int, right? The size has to be an unsigned int. So if I pass in 4 like this, so now I have dynamically allocate memory for what? For this I here, and this 4 here, this Malloc here is going to allocate 4 bytes of memory for me. Do you get it? It's going to allocate 4 bytes of memory here in this case. But here now, since this is an integer, right, I'm trying to allocate for an integer. What I'm supposed to do is I'm supposed to do something like this. We said that in pointers, when we're talking about pointers, we said the values of integers varies on compiler to compiler, right? Some compilers have 4 as the value of integer, sorry, the size of an integer, while some compilers has 2, right? So I can simply now say size of, I have to use the size of operator. Let me just clean this entirely. So I can simply say void here, asterisk malloc, right? So I will have to use the size of operator here. Then I will pass in what? Int here. So what this is saying is that I want you to allocate memory for me. And what is the size of the memory I want you to allocate for me is the size of integer. So if the size of integer on my machine is 4, it's going to allocate 4 bytes. If the size of integer on my machine is 2, it's going to allocate 2 bytes. So this is just what malloc does. So what about this void here? This return. Like I said, malloc returns a pointer. As you can see, this is it. Void and there's asterisk. By looking at this, you know that this is a pointer. Malloc returns a pointer. Right, and this pointer, this void here you are seeing here is a generic pointer. It can be manipulated. So why is malloc returning a void pointer here? The reason is because initially when you say malloc, or sorry, when you say void asterisk malloc like this, size underscore t and then size, right? This is the prototype. So the reason is when you say something like this, right, when you pass something like this, malloc does not know what you are trying to store in the memory that is being allocated to you, right? Malloc does not know what you are trying to store in the memory. Is it an integer? Is it a float? Is it a character? Malloc does not know. So since malloc does not know what you are trying to store in the memory that it has allocated to you, so that's why it's returning a void pointer here. So if you've decided to store, let's say, an integer in the memory that malloc allocates to you, so all you need to do is to typecast this thing. So to do that, you can just simply say int asterisk like this, then malloc, right? Then you simply say size of int. So this is what you are trying to allocate. This is what you are trying to store. You are trying to store an integer in the memory that malloc allocates to you. So the moment you do like this, you are telling malloc that, okay, now what is inside the memory you allocated for me is what is an integer. Okay, so that's why I said this is just a generic pointer, the void here. If it is a float you are storing here, you can simply add float here, right, and typecast it. If it is a character, I can simply add character here and typecast it. That's just what you need to understand about malloc. So this is just what malloc is. So malloc just allows you to dynamically allocate memory for your program. Malloc will not allocate memory that exceeds the amount of memory your program needs to run. And also malloc does not will not allocate memory that is less, right? That is less than the amount of memory that your program needs to run. Do you get it? So this is one good thing about malloc. So also now I said malloc returns a pointer. We've seen that. We said void asterisk right in the beginning. We also said char asterisk, that is if we typecast it. We also said int asterisk, right? Then malloc here. We said by looking at this, malloc is supposed to return what? A pointer. So since malloc is returning a pointer, I cannot do something like this. I cannot say int I, for instance, and then I will say I int. As you can see, this is typecasting. Int, then I will just say malloc, then I'll put my size here. I cannot do something like this because I here is not a pointer, right? And we said since malloc returns a pointer, we need a pointer to store malloc, right? We cannot store a pointer in just a simple variable like this I. We have to make this a pointer as well. So the moment I do int asterisk I here, I've declared I as a pointer, so I can simply say I is equals to this. So now malloc, the return value of malloc would be stored in this I here. So you need a pointer to store malloc. That's why I said for you to be able to use malloc, you have to know what a pointer is and you have to declare a pointer. Okay, so Now this Malloc here, we've explained when we're talking about recursion, we said there are, I think, 4 compartments of memory, right? So this, we said recursion takes what? Takes the stack. Whatever program you are doing using recursion, it is stored in the stack, right? The stack is responsible. That's the part of the memory that is responsible for handling recursion. So what about this this dynamic memory allocation? In fact, when we have the memory something like this, let me consider this as, let's say this is the stack here. So we said everything about recursion is handled here, right? And also not just recursion, the moment, or let me say all those automatic allocations that have been done in our previous program, automatic allocation, anytime you declare a variable, you initialize it, all these automatic memory allocation are done in the stack as well. So whatever memory that is allocated to you automatically by your operating system is stored in the stack here. Okay, so memory that is being allocated dynamically is stored here in the heap. Okay, this is the part of the memory that handles dynamic memory allocation. This is the heap. This heap is just like what should I even call it? Just like should I say a reservoir, a container that contains just free memory space. It's free, there is nothing there. Okay, so the moment you dynamically allocate a memory, or the moment you request a memory to be allocated to dynamically, then that memory will be allocated for you from the heap here. Okay, so one thing again, if we know that in automatic allocation, the moment these variables and everything is declared to you automatically, the moment your function returns, it's going to release that particular memory so that it can be reused, right? It's done automatically. Okay, it's done automatically. The moment you finish using the part of the memory that has been allocated to you automatically, the function automatically released that memory. Since you are done using the memory, it will release it, so allowing other programs to use the same memory as well. So, but in the case of this dynamic allocation, you as the programmer, you as the person writing the program, you have to deal with these things manually. Do you get it? You have to deal with these things manually. You have to tell the program to release the function, to release the memory when it is not using it. Unlike automatic, in automatic, like I said, it will release the memory, the space, the moment the function returns. The moment it finished calling, the moment it's finished running the function, it will return. But in this case, you have to manually free the memory, because if you don't free the memory, like I said, this heap here is a free let's say container of memory, a container that contains free memory. If you don't free it, if you have a function now and you use dynamic allocation to dynamically allocate memory for you, after using it, if you do not free it, the function will be called again, right? Let's say you have another function again, you call that function again, and that function also takes in another part of the memory in the heap. It will also run, and without freeing that same memory, another function will call again. It will also still use the memory. At the end, you find out that your heap is being exhausted. The memory allocated here, the free memory that is available in the heap will now be exhausted. So there will be no room for what? For another function to get memory dynamically allocated to them, because you have exhausted all the free memories in the heap here. Okay, so you have to for every function you use, for every function you dynamically allocate memory to, you have to free it at the end. So let's say if I have a variable like I here, and I use Malloc for instance, and it performs a simple task here, it allocates memory to it, right? If I do something like this, at the end, before exiting my function, I have to add this command here. I'll just say free, and then I'll pass the variable name here. I will simply say free I. So this means that all the memory, right, all the memory that is allocated to I here using this Malloc will be freed, because at the end I'm no more using the variable I. So since I'm done using it, I need to free the memory so that other programs will use it as well. So this is something you need to be doing. Okay, you cannot dynamically allocate memory without freeing it. I assure you, at some point your program will run out of free heap here, free memory here. So the moment you use Malloc, right? The moment you use malloc and pass in something, you want dynamic memory to be allocated to you, the function will return null. This means that there is no free memory that the function will be able to get from the heap. It has been exhausted. So whenever you dynamically allocate memory, you have to use free to free it. Okay, so the next thing we need to talk about is what is a simple command, which is the Valgrind. Is it Valgrind or Valgrind? I don't know how they pronounce it. Anyhow, it's simply something like this: Valgrind, something like this. So what is the function of this command here? Let's say you have a large program. For instance, you have a large program, and this program contains, let's say within the program, let's say you dynamically allocated memory, I think, let's say about 50 to 60 times or even more. If you are dealing with complex programs, there are possibilities you might do that. So you have a lot of programs, you have a lot of allocation of memory allocated to you. So there is possibility that you might forget to free them one by one, right? Like I explained just now, I said for each allocation you have to free it. After the function is what, after it has been used, you have to free it. So if you forgot, let's say, since there are a lot of them, there are a lot of memories allocated, let's say you forgot and you missed one of them, right? Let's say you missed one of them or two of them. So as you can see, that will be what? That will be a memory leak, right? The memory will be leaking. There will be a memory leak. So memory will just be going, will just be getting exhausted. We've already explained what will happen if you don't free the memory. So that is what will happen. So there will be a memory leak. So this Valgrind here, this command here, what it does is this: it will simply tell you if there is a memory leak in your program, right? So if there is a memory leak, if after compiling your program, if you run this command with the program, it's going to show you the number of memories you allocated dynamically, and it's going to show you also the number of memories you freed. So let's say you have dynamically allocated 10 memories. Let me say 10 bytes of memories, for instance. If you've used malloc, let's say in 10 places. So since you use malloc in 10 places, if you run Valgrind and you find out that the number of freed space is 8, definitely you know that your memory is leaking in 2 places, right? So if you run Valgrind on your program and you find out that the number of freed space is the same as the number of allocated space, then it means that there is no memory leak, right? So that's just what this Valgrind does. It shows you if there is any memory leak on your program. This is just the simple way we should explain about this malloc.